So as is always true, students very often want to immediately understand everything about something. That's not possible. This is brand new to us. You're going to go through some stuff. You're not going to know exactly what to focus on. You're going to have some integral rules, but sometimes no. So, okay. That was very useful, Jeff. I know. So this I can use a rule for. We know the rule for x to a power. What would the new power be?
It would have to be -2 plus 1.
Good. So I add 1 to the old power, and then I divide by the new power. That's it. And then what is this guy? And then, of course, plus c. So then I can write this as, if I want to, I can write it as -1 over x minus 3x plus c. But I would accept this too. That's fine. Either one. You guys all with me? So the one rule that's very helpful is the integral of x to the m. Because it's hard to kind of work with those directly sometimes. Part B, I always like to do that because somebody tells me it's pi squared over 2 or something crazy. I'm not integrating with respect to pi. I couldn't because pi is a number. So just like integral in -3 was -3x. What's the integral of pi dt? Pi t. Plus c. I like it. It sounds like the next evolution for Starbucks. You get pi t. I like some tea with some pi in it. Sounds pretty good. So what about part C? Who got part C simplified?
So you could simplify it to cosine theta because you would do sine over cosine.
All right, let's do this. Sine over cosine. Oh shit, Jeff. What do you write? Sine over cosine. Okay.
And then divided by 1 over cosine. So it's cosine plus. Yeah.
So then I multiply with reciprocal, the cosines cancel, and I get sine. So this becomes the integral of sine theta.
Which is negative cosine.
Good. Negative cosine theta
Plus c.
plus c. All right, did everybody follow? As I wrote some of that off the projector. So the trick there. All right, real quick. I'm going to say this right now. What if I had given you this? No. Over. Well, let's do this. Yeah, paper. You're messing me up. This is important. The integral of secant squared x over x. If I was going to take the derivative of this, could I just take the derivative of this divided by the derivative of this and be done? Would I be allowed to do that? If I want to take the derivative of this function, you with me? The derivative of this function, what must I use? Quotient rule. Integration is doing derivatives backwards. So if I am not allowed to differentiate different parts all at the same time, I sure as all hell am not allowed to integrate different parts at the same time. Yes? If a rule exists for derivative, it's going to be worse for integrals. If you guys kind of see that? Because integration is trying to do differentiation backwards. You guys kind of with me? So I would get, this is an answer very often for this. Do you guys see what that student did? What's the integral of secant squared? Where did secant squared come from? Tangent. What's the integral of x? 1/2 x squared, right? The integral of x. Do you see that? It's even worse than you're saying, Brendan. And they would tell me that's the answer. Hell no. Hell no. 2 reasons. I cannot differentiate the top and bottom and be done. So I definitely cannot integrate the top and bottom because integration will almost always be worse than any associated differentiation would have been. You with me? Oh yeah, L'Hopital's rule of limits. Yes? I'm just taking the derivative of that function. I would have to use quotient rule. Yes? Or bring the x out. Secondly, how would you take the derivative of this? Quotient rule. I couldn't just take the derivative of the top, derivative of the bottom. So that doesn't even work if I'm trying to check it. How do you check the answer to an integral? Take its derivative. See if it gets you back to where you started. Yes? Okay, so coming back to this. Sorry, that was a little side note. How do I do these two here? They both have the same first idea. Same as this one, actually. Simplify. So I can rewrite this x to the 7/3 divided by x squared minus 4x divided by x squared plus 2 divided by x squared. And then I can make that. What's 7/3 minus 2? 1/3. I lose an x here, yes, and I could bring this up. Now watch this. Do you guys remember the shortcut I told you? You don't have to use it. If I add 1 to a fraction, I just add the top and bottom and put it back over the bottom. So 1 plus 3 is 4 over 3. So that becomes x to the 4/3. If I divide by a fraction, I multiply by its. So the rule for a fractional power can become add 1 to it, which means add the top and bottom, put it over the bottom, and then put the reciprocal out front. That piece is done. This house is clean. Okay, and then what's the integral of 4 over x?
4 ln absolute value of x.
Look at that. And there's a little side note there. Do you guys remember? Let me finish this up and then I'll talk about side note. And then what would this become? What would the new power be? Yeah, -1 divided by -1. Yes, and the 2 comes to the right, so then this would become plus c. It would become 3/4 x to the 4/3 minus 4 ln x minus 2x to the -1 plus c. That's a nice way to write it. Now, quick side note. Do you guys remember? Here, I'm gonna bring back something traumatic real quick. Do you guys remember when we had something like this? You can do it, Jeff. What was I allowed to take out of that summation? Could the I squared come out?
No.
Why not? Because this symbol is letting I change. I is not the same thing in every term. It is the part that's actually changing in every term, yes? N is a constant. It's the same, so I can bring it out. Can I bring it all the way out?
No.
Because this guy sees him as the variable, yes? All right, you guys kind of with me? You guys kind of with me? Screw you, John. What does this here, this is one piece we just did. One piece. What does that see as the variable? That's a silly question. X. Can I take an X out? Hell no. Can I take a 4 out? All day long. Can I take a -4 out? All day long. Yes? You guys got it with me? This is huge. I could put a constant in. I could take a constant out. I cannot take a variable expression in or out that the integral cares about. This is huge. This relates to a big mistake people make with the next thing we're going to talk about today. So I can look at this as this, which becomes this. So you can always take constants out of the way, or if for some reason you need a constant, you can actually sort of figure out a way to get it in there. So you can take them out, put them in, however you need. But X's, ain't no way in hell. Okay. So what about this guy? Yeah, so this becomes that. Yes, we put this over here. Good Lord, Jeff. Here. So this is now, and what I can do for myself is this. See that? I can take that 2 out of the way if I want to. Yes? Oh, hell yes. Please understand, the biggest mistake students make, well, no. One of the big mistakes students make is they never integrate. You're going to understand what I mean. Before you can integrate, you might have to simplify, and the simplification could take a while. And then a student gets to the end, and they're not writing an integral, and they're like, well, that was forever, that must be done. No, you haven't integrated yet. So if you lose your integration symbol, you're going to be mean to yourself, and you might forget that, oh, I haven't done that yet. Does that make sense? Now, in general, if there's not a damn thing wrong with like taking this and saying, let me simplify this, and then I'll put it back in. But then it's on you to remember to put it back. Does that make sense? So you could do, I'm going to take this piece of it, and I'm going to take it over here, I'm going to work with it, and then I'm going to put it back in. Nothing wrong with that. That's beautiful tears. Yes? But then you just have to remind yourself, oh shit, I better integrate it at the end. Okay. Is everybody cool with this step? I just took the 2 out of the way. If you want to. Now, that interval is really stupid easy. What's the interval of 1 over x? Natural log of the absolute value of x. What's the interval of 1 over x minus 3? Natural log of the absolute value of x minus 3. Why? What's the derivative of the natural log of the absolute value of x minus 3? 1 over x minus 3 times 1. So here's the trick. If the inside function is a linear slope 1, it acts as if it was just x. The interval of 1 over x is ln absolute value of x plus c. The interval of 1 over x plus 11 is the natural log of the absolute value of x plus 11 plus c. It acts as if it was just x. Because the chain rule doesn't come up. So it's just a direct connection between derivative and antiderivative. Okay, maybe. So then this would become 2 ln absolute value of x minus 3. And if you wanted to, you could put the 2 up as a square, because you could do that with logs. Do it again?
For like the absolute value.
Yes.
Do we need to put it on both sides of the x, or do we put it on the other side?
What's inside the ln? There you go. So you better put it on both sides.
X.
Because if I didn't put absolute values, I would put parentheses around x minus 3. But since they're in absolute values, I don't need to. Okay, so coming down here. This integral is really crazy nice, yes? Integral of 3x squared, the 3 just goes back up. Do you guys see that? Or you could do 3x cubed divided by 3. Either way you go, you get x cubed. What's the integral of 1?
1x.
X. Now, real quick. This is what's going to really trip you up. I do not have to put plus c here. If I did put plus c, I would plug a 3 in, blah, blah, plus c, subtract, put a -1 in, blah, blah, plus c, the c's cancel, yes? So when I have a definite integral, we just don't put the plus c, because it would cancel at the end anyway. But for you, you sort of are like, oh shit, when do I put that plus c, right? So if you do it here, it'll cancel. So if you just want to be really careful, you can put plus c. I don't know if you guys are really with me. So let me do it like this. Here. If I do put plus c, I don't want to, but I will. When I plug a 3 in, I get 27 plus 3 plus c, minus, when I plug a -1 in, I get -1 minus -1 plus c. Do you see how the c's cancel? It would always do that. So we just, when I have a definite integral, I just don't even write the c, because it will always cancel. The same way we don't do chain rule when the derivative of the inside is 1. Why would I take the time to write that down there? Okay. So then here, what do I get? Huh? -1 plus 1 is, or did I do that right? No. -1, yeah, -1, thank you. And then -2, so it'll be 32. I'm not good with numbers. What's the integral of secant squared? Tangent theta. And then I just have to evaluate it. So if the thing I'm integrating is just the direct derivative of something else, you kind of go, yay, and you just write that. That's the derivative of tangent. And I have to evaluate that between 0 and pi over 4. What's tangent of pi over 4? 1. And what's tangent of 0? 0. And somebody else is pointing out, again, that's kind of a nifty thing. This kind of gross function between kind of gross integral limits comes out to be 1. That's semi-nifty. Yes?
Oh, I was going to ask if you can remove the
And then this one is a practice in why it's important to remember what the interval actually is. Come back to me. What is the interval of 2 over x?
Absolute value.
2 ln absolute value of x. And here that's definitely necessary because my inputs are negatives. Yes, well, they're supposed to be. There. So this would be 2 ln absolute value negative 1 minus 2 ln absolute value negative e. What's ln of 1? 0. And what's ln of e? 1. You starting to get the cadence of this? So it's the antiderivative, that's its own problem, and then you just plug in each limit if it's a definite interval. Okay. Now this one is a practice in understanding when you don't have that much work to do. This is the direct derivative of something, which means I know the antiderivative. I have to. Where did 3 to the x natural log of 3 come from? 3 to the x. The derivative of 3 to the x is 3 to the x natural log of 3. So what's the antiderivative of 3 to the x natural log of 3? 3 to the x. Do you guys get that connection? So then I have to evaluate that from 2 to 3, 3 cubed minus 3 squared, 27 minus 9, 18. Is that okay? Then you get this thing. Yeah, I like this thing. I meant to change that. No, I didn't. I did, but I decided not to. That's right. Good job, Pastor John. The interval of e to the 3t desperately needs to be easy because its derivative is easy, so it should be able to go backwards. But the interval is not e to the 3t because then the derivative would be 3 e to the 3t. Do I have a 3 there in front of it? No. So how do I take care of that? I want to kill the 3. That's going to. So I know the answer has to have this in it. There's no other way around it, but I know it's not that. Because this guy's derivative would be 3e, and I don't have a 3 here. So what must the antiderivative be? It must have something, a little trap set up that's going to kill the 3 when it comes down. I'm here, guys, die. Yes? That was dark. Sorry. Look at that for a minute. We're going to put a little mine outside this front door. Okay. So if I put over 3, now I've laid a trap. When I take a derivative, the 3 comes down, dies, I get exactly this. Evaluated between natural log of 2 and natural log of 3. Now, the plugging in step could get interesting. So it would be e to the 3 ln 3 over 3 minus e to the 3 ln 2 over 3. Some people will stop there, and that's bad. What do the e and the ln want to do? They just want to have a nice life. No, they want to kill each other, right? But what's in the way? And what can I do with this? Bring it up, right? This guy's like, stop, okay. It's like these guys want to kill each other. The 3's like, let me get out of your way. So I can put that up here, so these die. I can put this up here, so these die. So then I get 27 over 3 minus 8 over 3 is 19 over 3. I guess you guys are okay with that? Love you guys so much. The great thing about integration, if there is something, is you can write down a guess, take the derivative, and see how far off you are. How often will that work? A decent amount of the time. If you're off by a lot, that's when you're like, well, shit. I don't know if you guys understand what I'm saying. So if it's a constant you're missing, you can take care of that easy. If it's a variable you're missing, you're screwed. And that's what we're about to get into. The last idea of today. How you guys doing? Looks like you're holding on. Most of you guys are mostly awake. Okay. Yes?
Can you just explain D again?
Which one?
D.
D. Okay, so this here Why is this easy? We know the function whose derivative is cosine. Sine, right? So why is this easy? Because we know the function whose derivative is 3 to the x natural log of 3. It's 3 to the x. Now, I say it's easy. The more you know your derivative rules, the easier antiderivatives are. That's it. So a to the x's derivative is a to the x ln a. So where did 3 to the x ln 3 come from? 3 to the x. So what is the derivative of 7 to the x? 7 to the x times ln 7. So that is there, thank God, because I need it to be there, because if I have 3 to the x, it better be there. So when you're doing an integral problem, one good way to look at it is somebody took a derivative and they ended up here. I'm trying to figure out what the shit that they took a derivative of to get there. That ln 3 is there, which is great, because then that's just 3 to the x. They must have taken a derivative of 3 to the x. There you go. That's why that antiderivative is that. And then you plug shit in. Is that okay? By the way, I feel like sometimes my tone is like, well, this is easy. No, this is easy. But that doesn't mean it should be easy for you. This is not easy in that respect because this is all really new. And derivatives are relatively new to us because we've only been less than, 4.5 weeks or whatever? Right? So I need you to understand, my tone is trying to show you this isn't as hard as you might think it is, but I also want you to know I'm not like, you should know this. No, it takes a little bit for it to click. But what I'm looking at is the derivative of what? That's the question I'm asking myself when I'm trying to do an integral. What did somebody take the derivative of to get here? So if what I'm looking at is the direct derivative of something else, easy. If it isn't, shit. That's a perfect segue into the last thing for today. But you're not going to believe it. It's on the other side. It's all this. Oh, good. So some of you guys have done some of these. And the rest of you guys are like, well, they are just overachievers, whatever. If you haven't done this yet, take this guy's derivative real quick. Oh, just so you know, in case you've done some of this, we are going to develop a process where you don't have to have it all in your head. There's a process we can do for ourselves that we can just kind of follow the steps and it all kind of shakes out. And the process is called U substitution. Yes? 5-5. 5-4 is indefinite integrals, which are just antiderivatives, which I kind of laugh at because it says section 4.9. Yeah. So what is this guy's derivative? How does this work? What happens? The 9 does what?
Goes forward.
The 9 comes down to the 8th power now times the derivative of the inside, which is 4x. 4x times 9 is 36x. So I know this is the derivative of this. Therefore, somebody was trying to write this as a question. What is the integral of this? What must the integral of that be? Do I have any work to do on this? Now, in general, if I just gave you this problem, you got quite a bit of work to do. In the context of what we just did, the question I'm looking at right now is easy as shit. Remember, what's the question I'm asking myself when I see this? What's the function whose derivative is this? Okay, what is it? It's freaking that. So why was this easy? Because I happen to know that this is the derivative of this. Well, I always just happen to know that kind of thing. Hell no. Okay, but I just want to show you the motivation behind the process we're about to kind of develop. Okay. So this would be this. And again, and be careful, what's one thing I have to add on? Plus C, okay. Good. Now we know over here it's actually plus 0. But over here, if all we knew was this, I have to cover my ass, it could have been plus 11, because this derivative would have been 0. Is everybody decent with plus C? Plus C is a way for us to cover our ass. If all we know is that, its antiderivative is all that plus C, because it could have been plus 3. Because the derivative at 0 wouldn't be there anymore. So we got to cover our ass. Okay. Now, so in general, like I said a minute ago, if I'm integrating a function and I know the function that one is a derivative of, I am done. Well, how often will that happen? Not very, right? So, let's see if this makes sense. This was easy to do just now, yes? Why is this much harder?
Because we don't know what function gives us.
Yes, what is it missing? The 36x. Where did the 36x come from? What rule? Chain rule. Okay, so this whole process, this U sub dude, is integration undoing chain rule. Do you all agree with me? In fact, most of you guys should be pretty comfortable with chain rule. You might miss it sometimes, but you understand what it is and blah, blah, blah. You with me? But at first, chain rule is not the easiest thing in the world to get. Correct? Okay. So therefore, an integral of something to undo the chain rule that was to be done is going to look worse than it actually is. So this guy is going to be, not infinitely in this case, much harder to do because it doesn't have that chain rule piece. So this did not come from something simple. In fact, how would it integrate this? I would write this 8 times, foil, 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 and never finish it because at some point I went insane. And I'm in the corner somewhere, knocking the head on the wall. Foiling, foiling, okay. I don't know if you guys are really with me. A little bit? So, if I just have this one little thing here, easy as shit. Take that one thing away, shit. Okay. So down here, notice that, okay, what would need to be here in order for this to be doable? We haven't talked about how to do it yet. We had an example where we knew the answer because we knew where it started from. Yes? Ooh, go us. Now I don't. But I know what should be there. You guys see how to tell what should be there? What's the inside function in the part I can see? The part of that I can see, what's the inside function? X cubed plus 2, not the square root, because it's inside the square root. So what must be outside then to be the chain rule piece that would make this doable? What's the derivative of the inside? 3x squared. So if there was, the same thing here, look, what's the, here, I would need the chain rule piece to be there here. The derivative of the inside is 3x squared. Now, there's a 1/2 because of the square root, but that's a number. I need 3x squared here. I need at least x squared there to even possibly be able to do this. Okay, so right now, there's a process we haven't talked about yet, but I need it to make sense. In order for that interval to be doable, I need to see the part that would have been the chain rule piece. Okay. So, can you guys do these real quick if you haven't done these yet? Do exactly what I just did. So they should not be hard at all.
We're still arguing about C. Yeah.
Oh.
Can you just tell us what's
What's the
right?
matter? What do you think it is? Are you trying to actually do the interval?
Yeah.
Don't do the interval. I didn't say don't do it yet.
Well, we want to know, but we want to have fun.
Oh, okay. So what do you think it's supposed to be there?
I thought it was C squared, but then I don't understand why.
All right. Start with natural log of tangent. What is its derivative?
1/2.
Yeah, 1 over tangent times
Derivative
secant squared. Yeah.
Yeah.
Okay. Now, here's the key. If secant squared was here, here's what we could do. Let u equal tangent. What's du then?
C squared.
Secant squared. Dx. Yes. So wherever I see this, I'm sorry. Wherever I see, if I see this, I can replace it with du. Do I see that?
Yes.
Yes. So that's du.
Mm-hmm.
And this is natural log of u. Now this, to be honest, the only reason we would know this is because you guys did the problem where this derivative was this. In Calc 2, you'll figure out how to do the integral natural log using a process called by parts.
Okay.
So that's why these problems, I wasn't careful with them to make sure they were integrable, because that's not my point.
Yeah.
At this level, we couldn't do that, except we know it's this because we took the derivative and we got it in the homework somewhere.
Yeah.
Is that you guys with me? I think the other ones you could integrate.
Yeah.
Oh, that's why you thought you did something wrong because you couldn't integrate or something.
Well, I didn't know what to start with. What gives us ln tan x? It's that.
Yeah, it's this weird thing. Yeah.
That was correct.
So yes, and that I wasn't worried about that part of it because I wasn't going to make us do that. All right, guys. This is a you get it or you don't situation. So what would have to be here?
6x plus 6.
Yes. What about here?
2 minus 12x.
Yeah, 2 minus 12x squared. It's just the derivative of the inside, yes? So that would be the chain rule piece, yes? What about here? Secant squared. And what about here? This was a little bit different, but the inside is this, 4x cubed minus cosine x, so what must be up here? What's the derivative of this? 12x squared plus sine. Well, I'm sorry. Plus sine. Okay. Each of those integrals are now doable. So if they would have given me these inside, they're doable. Now, if I were a student in this class, I might be sitting there going, great, but how do you do them? So let's talk about that. So here is the idea. Help me out, guys. What's the integral of cosine? Plus
This is 5/4.
this is 5/5. 5/4 again is mostly indefinite integration, which is just antiderivatives. And it also talks about, how does it say it? One little thing about definite integrals, but there's nothing really new in 5/4. It's just applications of what we've already talked about. Okay, stay with me. If I wanted to do this, I cannot do that. Real quick, if you thought the answer was this, how can you show really quickly that's not the answer? What's the derivative of this? Let me put this like this, right? If you're writing this down, make it really clear to you, this is not the answer. Why is that not the answer? What's the derivative of this?
It would be 2x.
Yeah, it would be cosine x squared times the derivative of the inside. Is that what I had here?
No.
Is what I'm missing just a number?
Yes.
Is it? No.
Number and a variable.
There we go. If I'm missing a variable, I am screwed. Okay, maybe. So, let me see if you guys are cool with this. I'm going to try to explain this a different way than I ever have, which is very exciting. What's inside the cosine? X. So y equals x. So what's dy? I really want this to work because I think this is exactly what we need. So what's inside the cosine is x, yes? So what's the derivative of that? If I do the derivative of both sides, don't I get this? dy equals dx. So the derivative of x, the direct, what's called the total differential is dx. Are you guys all with me? We've done that kind of thing before, the differential, I think. So the way the integral is written, the function I'm working with, the derivative of the inside is also in there. Another way to look at this, I could have looked at it this way instead. What's the derivative of x? 1. Is there a 1 in there? Yes. So if I have this, what's the derivative of x squared? What's the derivative of x squared?
2x.
Is it in there also?
Yeah.
So that's doable. Now, that's great, Jeff. That's basically what I just said. But I want you to see, you all agree I can do that easy. Because the integral of cosine x is sine x. Why was that integral easy? Because what's inside, its derivative is in there also. This one should be just as easy. Because what's inside, its derivative is in there also, which means it follows the chain rule like it's supposed to. Here's how we do this. Okay. If I call that u, and I don't mean, like Natalie or whatever. If I call this literally u, what is du? You can do it. What's 2x dx. And I try to make a semi-big deal out of when we did the differential stuff, that it would be coming back later. Here it is. Today is the day. So if u is x squared, du is 2x dx. Okay, let me see if you guys find this is such a cool idea.
We solve for dx and substitute it in.
No. Oh, okay, sorry. It's unfortunate. You're going to have tutors telling you to do that shit. I wish they would stop. You're going to have my colleagues telling you to do that stupid ass shit. And I wish they would stop. But they just keep going because, well, it makes it easier for students. And it also makes students do weird shit. So, sorry. I'm sorry. It's just one of my little rants that I go on. If you solve for dx, you suddenly think everything's doable because you can always solve for dx. The problem is, what did I just figure out? I need an x, don't I? Do I have it? Yes. What if I didn't? Couldn't I solve this for dx still? Even if that wasn't there, I can still solve this for dx, and then I could throw it in, and then I could think I'm doing something, but I shouldn't be doing anything because I don't have what I need. So here's what I prefer. If I see a 2x dx anywhere, what can I replace it with?
X squared.
No, if I see a 2x dx anywhere, what does this say that equals?
Oh, du.
Do you? You with me? Do you see a 2x dx somewhere?
Yeah.
Don't you see it right here? Oops. There. Isn't that 2x dx? So I'm going to replace that with
Du.
du. If I see an x squared somewhere, what can I replace it with? U. Is the variable that's in my function the same as the variable the integral cares about?
Yeah.
You see what I mean by that? I'm sorry, the variable the integral cares about is u, because it's du, and the function's got a u in it. If I had an x anywhere left, I'm screwed. I did something wrong. It cannot work. I love you guys. Now, let me try to explain what we really just did. On one level, this is stupid easy. If I let u equal the inside, and then figure out what du is, I can then just write it in terms of u. Is this integral difficult? I've just got a u instead of an x. Who gives a shit? What's the integral of cosine u? Sine u, yes? So let's finish this problem up, and then I'll actually make sure you understand what we just did. Plus c, and what's u? What was u?
X squared.
Yes. u be x squared. Chaboo. Now, what we really just did, let me see if you guys are cool with this. When I had this problem, you all agreed this was easy as shit. This one, you're like, give me a lot of those, Jeff. Too bad I'm not going to. Because what's in the function, its derivative, is out there also. Yes? This is in that form. This is in that form. It's just hard to see. The function, the part that's inside the function, is its derivative in there? Yes, it's in there also. Well, if I call this u, all this shit is du. Now I can see, oh look, it's the same form. It's the same form. I just took all the extra shit out of the way. So let me immediately do this. There it is. All right. What if I had this instead? So you start to see, oh, I'm sorry, yes. Do you read?
How come in the beginning when you said if you're writing them down, say they don't equal each other? Like the cosine x squared.
Oh, we'll get there.
Oh, okay.
Baby steps. So this one is what this integral was nice because it had exactly what I wanted it to have. The next thing we'll do is talk about how to tweak things if it doesn't have what I want it to have. Yes. I can only tweak things if I'm missing a number. If I'm missing a variable, I'm screwed. What's the inside function here? X cubed, it's inside the cosine. And what's the, so if I let u equal x cubed, what's du? 3x squared dx. So wherever I see a 3x squared dx, I can replace it with du. Do I see a 3x squared dx?
Yes.
Yes. And x cubed was u, yes? Now again, do you see how I ended up with the same exact thing? Because this is in the form cosine shit d shit, yes? If the shit is x squared, the d shit is 2x dx. You with me? This is also in the form cosine shit d shit. Cosine shit d shit. So, as long as this piece is here, then I could do this u substitution. This is, let me see, how can I get this? Trying to think about how to, when I write this, whatever this is, what is this? Whatever this is, what is this? It's derivative. Yes? It's differential really, but it's derivative. Yes? You with me? So I can integrate anything that looks like that. It would just be sine of u. If it looks like that, its integral is easy. So you could imagine, therefore, you could imagine all kinds of situations. If I had a secant squared out in front of cosine, what would have to be inside of it? Tangent. Because what's the derivative of tangent? Secant squared. Yes? So that is in the form cosine shit d shit. Cosine shit d shit. Alright. Teach math is a lot of killing, and there's a lot of shit up there. I'm sorry. So this process, what it's trying to do is just trying to take what I'm looking at and make it easier to look at. What's the important stuff going on in this? The outside is the derivative of the inside. That's what's important. Which means the integral should be easy. Just like that very first problem with a 36x blah 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 to the 8th power. Yes? Why was that an easy problem? Because the outside was the derivative of the inside and it was easy to go backwards. So, anytime I see in my integral a function whose derivative is in there also, u sub might work. So for example, what if I had this? No, there we go. Do you see a function? First off, dear God, before today, if I gave you that problem, you could come up and kick me in the leg. You were free to do that, so thankfully I didn't do that accidentally. So I didn't have like 30 people kicking me in the leg. Before today, you could not have done. There's no way you could have done this problem. Besides throw it to ChatGPT and say, please help. Do you see a function in there whose derivative is also in there?
Yeah.
What is that function?
The LMX.
LMX, yes. When you see that, you're like this. You say to yourself, let me try u sub. Now, for us, that's the only other thing we're going to know. If you take Calc 2, the entire first chapter 7, 7.1 through 7.8, every section is learning a new process. So then you go, what's the first thing you try? U sub, because that's the easiest. If U sub works, you go, thank God. If that doesn't work, you're like, shit, let me go to the next thing. That doesn't work, let me go to the next thing. It's not quite that bad though, because certain things about the problem are going to make it easy to tell which thing to use. So for us, it's either going to be, can I integrate it directly, Or do I have to use u sub now? Yes? If I see a function in there, so what am I going to let u equal?
ln of x.
Yes, because the du is 1 over x dx. Do I see 1 over x dx?
Yes.
Totally. There's a 1 over x dx. So that is du. And then what's secant squared of?
Of u.
U. And what's the integral of secant squared u?
Tangent u.
Tangent u plus c. And then what's u?
ln of x.
How do you check your work? Take the derivative. What's the derivative of this? What's the derivative of tangent? Secant squared of this times the derivative of ln is 1 over x. Secant squared of this over x, that's exactly what we had. So that's the right answer. I'm sorry, somebody had a hand up. Yes.
Why did we drop the t?
Say again?
Why did we not write tangent u and then du plus t?
Oh, okay. Several things. This had to do with the width of the rectangles, and this was the height of the rectangle. So together they make the area, and then I add them all up. So it would go into the area if I was looking at it that way. What I want us to transition to is this is one symbol. This is one symbol. This tells me to integrate. This tells me what I'm integrating with respect to. When I integrate, if I take the square root of 9, I get 3. I don't get square root of 3. The symbol's gone, correct? If I do what the symbol wants me to do, the symbol goes away. Does everybody agree with me? Good. So if I do the integral, the symbol goes away. What's the symbol? This.
Because those are bookends, right?
Bookend. It's the only symbol, well, okay. No, there are some other ones. It's the only one we know at this level where that's like a bookend symbol. This is trippy. This is one symbol. Sort of like, and this is what I said the other day, the square root has a well-defined inside. This defines the inside by leaving a blank space in the middle. The same way this is one symbol is how this is one symbol. Good. Again, there's a lot of things that were chosen in the past that if I could invent a time machine, it would be amazing. Yes? Number one, time machine would be nice because then there's a lot of stuff. Yes, especially in the recent past. Baby Trump, no. But like the square root symbol even is problematic. But the integral symbol is weird because it is split. Okay, I'll stop. All right, now let's try a problem where we don't have what we need. Okay, I'm gonna do two types of this. The first one we can do, the second one we can't. What do you got, Jeff? I don't know, Jeff. Here we go, perfect. 90-something% of the time, u is going to be the function that is stuck, that is inside. The other percent of the time, it's going to be whatever function is in there whose derivative is in there. That's the most important thing. When I'm doing u sub, there's a piece of what I'm looking at whose derivative is also in there. That's what needs to happen. 90% of the time, or roughly, what's inside? What's the inside function? So x squared minus 3. That's what I'm going to let u equal. What's the derivative of 7x squared minus 3? Huh? 14x? Good. Sorry, can't see. Do I have that?
No.
What am I missing?
A 14.
Now, the important thing is, okay, numbers I don't give a shit about. Poor little numbers. We made them and we're like, that's the good toy. I can make them show up or not whenever I want to. And I'll show you in a minute how. If I was missing the x, I am screwed. I'd have to wait till Calc 2. If the x wasn't there, that's a Calc 2 problem. That's a Calc 1 problem. So a little teaser. If you're never going to take Calc 2, too bad, you're never going to know. And you're like, oh, okay, yes.
Because 14 is a constant, could we put the 14 in front of the whole thing?
I can't just magically make a 14 show up. Who has never seen Raiders of the Lost Ark? Okay, sorry. And you're like, I am not going to see that shit because they don't. It was when they knew how to make movies. But for everybody else, and I'm sure you've seen this somewhere referenced. He has the bag of sand and the gold statue. Yes? And of course, he didn't balance his equation correctly, and the boulder was coming like, I have graded you and determined you incorrect. Oh, shit. So that's what I see myself as. It's the big ass boulder of man of truth. Okay. Here's the cool thing I can do. You ready? Here, Jeff. We're getting official now. Everybody stand back. I don't have my red pen. That would have been even better. All right. If I put a 14 here, I am so wrong. I am doing a different problem now, correct? If at the same time I put the sand down, I also take the statue away, then I've done nothing. Yes? Didn't I just multiply by 14 over 14? What can I do that to? Everything. Anything I want to. It doesn't make sense sometimes. Why does it make sense here? Because can I find my du now? I need you guys to see this. If it's a number I am missing, I can put what I need, and then the outside I can put the reciprocal. You with me? Why? Because I just did nothing. Hey, Jeff, you did nothing. So that's legal. I didn't change the problem. It's the same stupid problem. But I've reorganized shit. What can I replace this with? du. The 1/14 is still there, yes? And then, let me write this better. It's to the 1/2 power. What's inside of here? You. It's me. U sub leads to weird grammatical situations like, what is you? I want this English teacher to be walking by. What is you? Okay, this math people. Is somebody, so somebody asked earlier, which is beautiful, what if you don't have what du needs? Well, I can give it to myself if it's a number. If, for example, this would have been cubed, what would du have been? It would have been 21x squared, yes? What am I missing then? Another x, which tells me I stop. Either I chose the wrong thing or it's an impossible problem. Off the top of my head, I don't think they gave you any that are impossible, which would be nice. I'm pretty sure they didn't. But do you guys see that? If I'm missing a variable, I am screwed. Because what am I not allowed to take in and take out and put into an interval? The variable. Numbers can go in and out all they want to. So what I really did here was I really did this. I put a 14 over 14 outside, and I brought that in. I put a 1 out front, and then I made it 14 over 14, and then I brought the 14 on top in. That's what I really did. But I always do it like, put what you need, and then balance it. Put what you need, and balance it, yes? If you don't balance it, boulder's coming for you, yes? Okay. Oh, it's in the museum. Okay. So what is the integral of u to the 1/2? What's the power become? 1 plus 2 is 3, right? When you integrate, you add 1. How do you add 1 to a fraction? Add the top and bottom, put it back over the bottom. So what do I multiply in front by? 2/3. Plus c. Now, this will be bam, bam, 7. This will be 1 over 21. Jeff, sure, that's fine. Write more stuff. And then what's u? What was u?
7x.
Yes, 7x squared minus 3. So that's the last thing you do is make sure you go back to x. Don't go back to your x, but bring the variable x back. You be careful. Well, I know, sometimes it works. Gotta be careful. Maybe? Is that? Alright, this is brand new shit. So it shouldn't sit well with you quite yet. Right? Understandable. But the whole idea of u sub is to kind of remove all the excess shit just so you can see what the form of it really is. You work with the form and then you bring back the details. So let me give you a problem that, let me see what you think about this problem. What do you got, Jeff? I don't know. This is wrong for so many reasons, but it's okay. Even if it would have made it, you couldn't have done it. But why immediately do you know you cannot do this? Yeah. What would you let u equal?
3 minus x cubed.
And what's that guy's derivative? Yeah, you ready? This is the way I would say it. I would let u equal 3 minus x cubed, the derivative of something x squared. Because numbers, I don't give a shit. I can make them work. They work for me. We made them. Okay, stop. Do I have x squared?
No.
I'm screwed. I'm screwed. And I know I didn't make a mistake because that's all there is that I could try to do. You see that? So that's a problem I could not do. Well, we could not do right now. Go far enough, maybe someday. So let me give you this. Let me go ahead and do this. Okay. So I've got on this page. Oh shit! Let's do this first. What about this? Let me throw something new at us. Let me think. Okay, let's do this. Yeah, let's do this. I like it. Let's see. You can do it, Jeff. But I'm gonna throw a little twist. A little twist. From 1 to 2. Oh my God, Jeff. Holy shit. Wait a minute. I did not think about this. Oh, that's gonna be gross. Oh, too bad for everybody. Let me think. That would be 18, and that would be 21. Is there a way to salvage that? I'm not gonna worry about it. All right, let's do this. Hold on, let's do this. Take the 1/3 away. I'm gonna salvage this and make this. Yeah, leave this as -5, but make this -4 and make this 3. There we go. Okay, I'm gonna save this.
It looks like we made it worse.
Huh?
I said it looks like we made it worse.
I totally looks that way, but it didn't. Okay. So can you guys start to see why I know u sub is gonna work here?
Axis.
Because there's an x cubed that's stuck somewhere whose derivative is in there also, minus the constant, but who cares? So I have an x cubed and I have an x squared, u sub should work. So what am I gonna let u equal? And what's new with this problem, by the way? What's brand new on this problem? What kind of integral is it?
Definite.
Definite. So, can somebody tell me real quick, what the hell are these numbers all about? They're values of what? X. These numbers are what this variable is doing. That's what a definite integral always means. And what are we about to do? We're about to take x and replace it with, oh shit. So, man, let's start this off as if we didn't notice that. U equals what?
X cubed value.
Okay, and what's du?
3x squared dx.
Kick ass. So, let's see. Let's do the balancing act, yes? I wish this wasn't a 4. You agree? So what do I want here instead? What do I wish was here?
1 of 3.
A 3. I wish a 3 was there, yes? So I can take the 4 out. And how do I put a 3 here instead? How do I balance that? There. Take the 4 out and put an over 3, so I'm allowed to put a 3 inside. And sure enough, what's 4/3 times 3? 4, so I didn't change anything. I just rearranged it. So do me a favor. Write the integral, but leave these blank for right now. What is 3x squared dx?
du
That's du. And then how do I rewrite this?
u to the power of 11.
Now, here's the thing. Ready? Did I look at this right? I did. Go, Team Jeff. I did. Oh, look at me go. Okay, sorry. Remind me, these are what does?
Those are values
X.
of x.
Those are what x does. What do I need there now?
You.
What u does. And this is, again, I want another English teacher to worry about. Do we have a relationship between u and x? Yeah, we do. This one. No, Jeff, you're so smart. You know what I did? I was trying to think backwards. I did make it worse. Go, Jeff. Oh, too bad. So, when x is -4, what's u? We're gonna keep going. I'm gonna make you own my mistake. So when x is -4, what's u?
-4 cubed.
Good. So when x is -4, I get -64 minus 5, I get -69. Bam! What about if x is 3? Yeah, 27 minus 5, 22. So the trick with definite integration, when you write u equals function of x, you can immediately figure out what the new limits are going to be. In my head, I was thinking backwards. I was making the u and the x, and so it's terrible. So good job, Jeff. This is going to be horrendous, and I love it. So don't worry about it. Those numbers, don't worry about it. What's the integral of u to the 11th? What's the integral of u to the 11th? U to the 12 divided by
Divided by 12.
12. And I want to evaluate that between -69 and 22. Now, I want you to realize something. Do I have to change this? Do I have to bring x back? No, because I know what u is doing. When I was a student and I learned this, I would not change my limits. I would write this and then I would bring x back and then I would plug the original numbers in. This is better. Trust me. Especially if you're going to take Calc 2, especially if you're going to take Calc 3. And unfortunately for us, we have a teacher that can't think ahead correctly. So then we have these 22 to the 12th. Now I could simplify this a bit. So this would be 1/3, so this would be 1/9. Let's do that. 1/9. Then I have 22 to the 12th minus -69 to the 12th. And then, whatever the shit that is. Okay. So let me do this. I'm going to give you a handout that's got 4 examples on it. Holy shit. I know. Poor little number. This is almost perfect. So I've got 2 examples of indefinite, 2 examples of, I think I did. Yes, 2 examples of definite. So right here is my little side work to change from what u is to, what x is to what u is. So like on this example, I let u equal this business. So when x is 0, u is 6. When x is 1, u is 1 plus 2 plus 6, 9. So then my limits become 6 to 9 when I replace all my stuff. Are you guys kind of with me? A little bit? No? All right. This problem. what would you let u equal?
Stuff inside the square.
Yes, this stuff.
No.
So I'll let u equal that business. So du is 2x plus 2. And then all the top is missing is a factor of 2, and I can make that show up by doing this balancing act here. Yes? Put a 1/2 out front, so you can put a 2 inside. Now, if u equals this business, and x is 0, what is u when x is 0? U would be 0, 0, 6. U would be 6. So when x is 0, u is 6. So I put a 6 there when I bring the u stuff in. When x is 1, what's u? 1 plus 2 plus 6 is 9. So when x is 1, u is 9. So in place of 1, I put a 9 when I bring the u stuff in. I need the numbers on my integral symbol to represent what the variable that's in there currently is doing. So the original problem says x is going from 0 to 1. I said, that's nice. I'm going to replace that shit with u, so I better put what u is doing now. I might be pushing too much. All right. So let's do this. I think that's play for today. Next time, we'll look at the other side of this, which is some practice problems. Obviously, if you want to get a head start with those, you can. Tomorrow, the quiz, first thing, it's 474951. And then I'm going to have a practice test for you guys tomorrow. Okay.
Another spicy day.
Spicy.
Yeah. Professor, do you know what happened to Mike Lyons?
What do you mean what happened to him?
His classes were transferred to Raymond Punk. At least
Oh, I think he just switched. He decided to do an online. He's teaching an online stats course right now. I think he originally was going to teach one, but I'm not sure about specifics, but he wanted to do an online course instead. Yeah. He's still around. Yeah.
they didn't update it on what was not what.
Thank you.
Self.
No, the test is Monday.
Thank you.
Yeah. Oh, it still says.
Lyons.
Oh,
This
no.
summer and fall.
No, he's back on campus in the fall.
Did you want to send it now?